Hey guys, Mosh here. Today we're going to talk about bubble sort. Bubble sort is one of the many sorting algorithms that come up in coding interviews all the time. In fact, these days more and more companies ask data structure and algorithm questions in their interviews to see if you can think like a programmer. In this video, I'm going to show you how bubble sort works and how you can implement it in Java. If you don't know Java, that's perfectly fine. You can still follow along and implement the bubble sort algorithm in your favorite programming language. Also, if you want to learn Java, I have a comprehensive 2-hour tutorial for you here on my channel. The link is below this video. So let's jump in and get started. The first sorting algorithm we're going to talk about is bubble sort, which is the simplest of all sorting algorithms. Let's say we have an array of integers, and we want to sort this array in increasing order. With bubble sort algorithm, we scan the array from left to right, and if items are out of order, we swap them. So we start off by comparing the items at index 0 and 1. If the right item is smaller than the left item, we swap them because we want to sort this array in ascending order. So here, 2 is smaller than 8, and we have to swap them. Now we compare the items at index 1 and 2. Again, the right item is smaller, so we have to swap these items as well. One more time. Again, we have to swap these items. And one last time. Okay, this was our first iteration or first pass. We need multiple passes to fully sort this array. At the end of each pass, the next largest item moves to its correct position. So here 8 is in the correct position. This is why we call this algorithm bubble sort, because after each pass, the next largest item bubbles up and moves to its correct position. So in the next pass, the next largest item, which is 4, will bubble up. Let me show you. Once again, we compare the items at index 0 and 1. These items are in the right order because 4 is greater than 2. So we don't need to swap them. Let's look at the next 2 items. 1 is smaller than 4, so we should swap these items. And one more time. Again, these items are out of order, so we need to swap them. And the last 2 items. These items are in the right order, so we're done with the second pass. Now, 4 is in the right position. As you can see, our array is almost sorted. We just need one more pass to swap 2 and 1, and then our array will be fully sorted. So let's do that real quick. All right, our array is fully sorted. Now let's talk about time complexity. If you're not familiar with this concept, you need to go back to part 1 of this series where I talk about big O notation. So what's the time complexity here? Well, in the best case scenario where our array is already sorted, we need a single pass. In the worst case scenario, the array is sorted in reverse order. Here we need n passes. Now, in each pass, we need n comparisons. Well, more accurately, n minus 1 comparisons. So if we have 4 items, we need 3 comparisons, right? So bubble sort runs in O of n or linear time in the best case scenario, and O of n squared or quadratic time in the worst case scenario. If you go to bigocheatsheet.com, you can see a visual representation of these growth rates. As you can see, O of n squared is very inefficient because it's in the red area. So this algorithm gets real slow as the amount of input data grows. Later, I will show you better sorting algorithms that run in the orange or yellow areas. But before we get there, let's implement bubble sort in code. So pause the video, spend 20 minutes and try to implement bubble sort on your own. Then come back see my implementation. All right, here in our project, let's add a new class. We call it bubble sort. In this class, we need one method, public void sort. We give it an integer array and call it array. Now here we need a loop to iterate over this array multiple times. In each iteration, the next largest item will bubble up and move to its correct position. So a typical for loop, for I, we set it to 0. As long as it's less than array.length, we increment it after each iteration. Now here we need a second loop, and we use this loop to compare every 2 items of this array. So let's call this loop variable j. We can set it to 0 and start from the first item, or 1 and start from the second item. So here we'll compare the second item with the previous item, okay? So we set j to 1. As long as j is less than array.length, we increment it after each iteration. Now, in each iteration, we're going to compare the item at index j with the previous item. So, if array of j is smaller than the previous item, that means these two items are out of order. So we need to swap them. How do we do that? Real easy. We've done this before. So we use a temporary variable and copy array of j into this variable. Then we set array of j to array of j minus 1. And finally, whatever we have stored in the temp variable, we use that to set array of j minus 1. So array of j minus 1 equals temp. That's our bubble sort. Now, I prefer to extract these three lines into a separate method called swap. This will make our code cleaner and more readable. So let's declare a private method here, private void swap. We need to pass our integer array and two indexes. So index 1 and index 2. Now, once again, we use a temporary variable. So we set temp to array of index 1. Then we set array of index 1 to array of index 2. And finally, we set array of index 2 to temp, right? Now, back to our sort method. Instead of these three lines, we can call swap, pass our array and two indexes, j and j minus 1. Now, because we have a single statement here, I would prefer to get rid of these ugly curly braces. That is better. So we're done with this implementation. Now let's test it. Back to the main class, let's declare an integer array called numbers and set it to 7, 3, 1, 4, 6, 2, and let's add a duplicate like 3. Now we create a sorter object. We set it to a new bubble sort, and here we call sorter.sort, pass the numbers array here, and finally we're going to print this on the terminal. So here we use arrays.toString to convert this array into a string. So we pass the numbers array and run our program. So as you can see, our array is sorted. Now let's test the edge cases. What if we have, let's say, only two numbers here? Our algorithm still works, beautiful. What if you have a single number? Still working, beautiful. What if you have an empty array? No problem. So we have successfully implemented bubble sort, but there are a couple of places where we can optimize our implementation. Let me show you. So back to our bubble sort class. Here we're assuming that we need n iterations to sort this array. But what if our array is already sorted or partially sorted? Then we're not going to need n iterations. We need fewer iterations. So here I'm going to declare a Boolean variable called isSorted. Now in every iteration, we want to set this to true and assume that the array is sorted. If our assumption is correct, then we'll return immediately. So let's add curly braces here. In every iteration, first we set isSorted to true. We assume that the array is sorted. Now we start comparing items. If we end up swapping two items, that means our assumption was wrong. So right after swapping, we need to set isSorted to false. However, if we don't do any swaps, that means our array is fully sorted. So after this for loop, we can write an if statement. If the array is sorted, we can return immediately. There's no need to iterate over this array one more time. That is one optimization. We also have another optimization. Look at this inner loop. Here we're going through the entire array comparing every two items. But as you learned, in every iteration, in every pass, the next largest item bubbles up and moves to its correct position. So we don't really need to compare all the items in this array. We only need to compare all the items that are not in the correct position. So in our first pass, no items are in the correct position. That means we should iterate over all the items in this array. In the second iteration, one of the items is in the correct position. So we need to look at all the items except the last item. So here, we can change this expression to array.length minus I. Again, in the first iteration, I is 0, so we're going to look at all the items in this array. In the second iteration, I is 1, so we'll look at all the items except the last item. So these optimizations make this algorithm run a little bit faster, but its time complexity is still O of n squared. Hey guys, Mosh here. I wanted to let you know that this video is actually part of my Ultimate Data Structures and Algorithms course. The complete course is 13 hours long, and I've divided it into 3 parts so you can take and complete each part easily. If you're serious about learning data structures and algorithms, I highly encourage you to take this course and learn all the essential data structures and algorithms from scratch. It's much easier and faster than jumping from one tutorial to another. We'll be talking about various types of data structures, such as linked lists, stacks, queues, hash tables, binary trees, AVL trees, heaps, tries, graphs, and various types of sorting, searching, and string manipulation algorithms. The course is packed with almost 100 interview questions. These are the interview questions that get asked at companies like Google, Microsoft, and Amazon. You can watch the course online or offline, anytime, anywhere, as many times as you want, and you would also get a certificate of completion and a 30-day money-back guarantee. It's exactly like this tutorial, it just has more content. If you're interested, click on the link below this video to enroll in the course. Thank you and have a great day.